This is our final video in our series on multiplying and factoring polynomials. So before we begin, we need to review our other factoring patterns that we've learned up till now, because we have one more factoring pattern to go through. So go ahead and do these warm-up problems, pause the video, and come back when you're done. Now number one was kind of a toughie. Perhaps you stopped when you just got this trinomial, but truly you could have factored that further into those two binomials. This one you're done. I tried factoring this one, but it didn't work out. So when that happens, you're just done. You factored it completely. And here's how we factored a polynomial that had two terms, and here's how we factored a polynomial that had three terms. Today's lesson is factoring a polynomial that has four terms.
Jaywalking. Now we've got Reno on our trail. We've been through this before, but it still doesn't make any sense.
When you see a polynomial with four terms in this chapter, you're going to try to factor it by grouping. And if you do it right, the chances are it's going to work out. Factoring by grouping is named that way because what you do is group your first two terms separately from your last two terms. And then you look for a common factor, or the GCF, the greatest common factor, of each of them separately. So I'm looking only at the first two terms right now. Do you see a greatest common factor among them? 5x cubed would be the greatest common factor, and you go about dividing each of them by 5x cubed, which gives you x plus 4 left over. And then you kind of leave that off to the side and go on to your second two terms and factor out a greatest common factor if it has one. Well, that would be a 6. And it was a positive 6, so you write that as a big plus sign there. And when I divide the 6 out, I get an x plus 4. Now hopefully you should notice something, and this should always happen if factoring by grouping is going to work. The numbers inside these binomials and parentheses should match. Because these match in both of these terms, the x plus 4 in this term and the x plus 4 in that term can be factored out as the greatest common factor again. X plus 4 is truly the greatest common factor amongst these two terms. And then what's left over? Well, if I divide this out by an x plus 4, you're left with 5x cubed. And if I divide out an x plus 4 from this term, you're left with plus 6. And you have just factored this by grouping. It's hard for kids to realize the difference between here and here. Why did we do this extra step? Remember your definition of a factor. There are two things that are multiplied together that get you a product. In this form, these are not being multiplied together. You have an addition sign. But once you factor out these common factors, you turn it back into multiplication. And so it's imperative that you write it back in this form, because now these truly are factors. I'll do two more examples with you. Your number one job is to realize you have four terms, and that should trigger, hey, maybe I can factor by grouping. These two get grouped and those two get grouped. Your next step is to find the greatest common factor of these two. Well, that would be 2x squared. Dividing 2x squared out of each of those terms give you an x plus 3. Well, we're done with that group, so let's move over to this group. And the only thing they have in common is a 3, leaving you an x plus 3. And there it is again, where these two match. Take it the step further and factor out or divide out an x plus 3 from each of these. When I divide this first group by x plus 3, you're left with 2x squared. And when I divide this by x plus 3, you're left with plus 3. And now you're factored. Next example. 4 terms means factoring by grouping. So in this first set, I have, and I'm going to move way down here, a common factor of 5x squared, leaving me with a 2x minus 5 on the inside of my parentheses. This, I could pull out a positive 2, and I'm left with 2x minus 5. Again, these should match. And if you have to manipulate signs, say I needed to pull out a negative 2, you're certainly welcome to do that. These signs need to match. Pull out your common factor of 2x minus 5 from each of those and fill in what is left over, which would be a 5x squared plus 2. Let's have you practice. I'm going to do this first one with you because it turns out to be a little different. It kind of has that sign issue I talked about. So let's factor it by grouping, and I'm going to pull out an x squared from the first group to get 2x plus 1. Now in the second group, knowing that I need to have a positive sign inside of that parenthesis, I'm going to pull out a negative 7. Because once I do that, I get a 2x plus 1 coming out. Again, if you accidentally pulled out a positive 7, you would end up with a negative 1 here. So just know that you can change the sign for that factor you pull out to make sure these truly match. And then you pull out your common factors and finish it up by dividing them out to get this. I'm going to do this one with you too because it's another special kind of thing that happens. And when I factor out of these two, you end up with your 2x squared coming out, leaving you with a 3x plus 4. And now when I move over to factor this group, you notice that it's already the thing I needed, the 3x plus 4. And so what you do officially in that situation is you factor out a 1, because you know it won't change it, but you absolutely need to have that there for the next step. If that was confusing to you, just multiply all this back together and see that you get that product back out again. And then factor out your 3x plus 4, and then your leftover is 2x squared plus 1. Alright, now it is your turn. So you try these two, pause the video, and come back when you're done. That's how those answers look. And then, of course, there's always one more little thing. So if you notice in the blue problem, our job is to factor completely. And when I'm looking at it right now, I can see that there really is another greatest common factor that occurred between these two parts of our expression. And so you really should, if you want to be very particular and mathematically precise, pull out the GCF from these two so that we're factored completely. And the GCF that they have in common is a 3x. So when I pull the 3x out of that particular binomial, you end up with 3x squared plus 2. Okay, and now you're truly factored completely, and there's nothing else we could do to break anything down. If you ended here, I'm okay with it because we're just learning this stuff, and we can save this last line for Algebra 2.